All right, here's a second example and kind of a more interesting example of composing a new function. So f of x equals x squared, g of x equals the square root of 1 minus x. So let's first start by composing f with g. So that's going to look like f of g of x. So we start writing f of x, and whenever we come across an x, we put g of x in. It looks like that's the first thing that's going to happen. So we've got the square root of 1 minus x. There's my g of x. And remember, the original f of x was squared. Okay, so there's my new composition. And we want to calculate the domain or figure out the domain. Let's go back and figure out the domain of each one of the original functions. All right, so f of x, quadratic or parabola, domain is all real numbers. And g of x, what is the domain of g of x? Well, we know that we have to have a positive number or 0 under the radical, so we can't have x be greater than 1. So we're going to have our domain be x is less than or equal to 1. So now let's figure out what our new domain is. Now, you are going to be so tempted to cancel these two things out, and I'm going to urge you to not cancel them out, because you get something different when you cancel them out. So what I want you to do is graph this, or actually you could just watch me graph it. I have it graphed right here. So here's my y equals, and just in y sub 1, that's all we're concerned with right now in y sub 1. There it is, the square root of 1 minus x, and then all of that is squared. And when I look at the graph of that, this is what I have. Interesting. And actually that little point there, I think I have my stat plot on, so ignore that little point, but there's that line, and it's kind of, I don't know, it's kind of strange. Let's look at the data table and see what this looks like. Well, it looks like when we have 1 in for x that we get an output of 0, which is good. But when we put in x values greater than 1, we don't get an output. So there's an error there. The function is not valid there. But when we put in values less than 1, we get out an output. So the domain of this one is x has to be less than or equal to 1 with this composition. Okay. So let's do another one. Let's compose g with f. G composed with f. And so that's going to look like g of f of x. So we're going to start by writing g of x, square root 1 minus, and as soon as I get to x, I stop, because that's where I'm going to put in f of x. So here's my f of x, x squared. Okay, and then it looks like I'm done. Okay, so now I got to calculate or figure out the domain of this new function. Well, we know we can't have a negative under the radical, so we're going to set that equal to 0 to solve. 1 minus x squared equals 0. And then we're going to add x squared to both sides, so we get 1 equals x squared, and then when we square root it, we have x equals plus or minus 1. So the domain suggests that x cannot be equal to plus or minus 1. Let's go take a look at the graph, and I've already got that graphed for you. And let's go back to y equals, and actually we can clear the y sub 1 because we used that in the last example. And then looking at the other one, I have graphed here. Here it is, the square root of 1 minus x. And let's look at the graph. And oh, that's hard to see with a standard window, but you see a little, what looks like a semicircle right there. So, not zoom, let's do window. Maybe set it to -4 to +4. And let's see if that looks a little better. Yeah, that's a little better. Okay, let's go look at our table and see what that looks like. Alright, so let's put that right in the middle of the screen. So it looks like from -1 to +1, we have a valid domain, and when we get smaller than -1, we do not have a domain any longer that's valid. And we get larger than 1, we don't have a domain that's valid either. So that kind of confirms that what we had over here, plus or minus 1, kind of like our boundary values, but we can expand that a little further and say now that that can go from -1 up to and including +1. So it actually can be 1 and -1, because that would give us 0, and 0 is valid. That's a valid thing under the square root, and you can try that on your calculator if you just want to make sure that that works. Okay, so we got plus or minus 1 from our exercise here of calculating it by setting it equal to 0, and then when we graphed it, we confirmed that we could actually be 1, we could actually be -1, and everything in between. So there's my domain, -1 up to +1 including. Let's do one more example here. And let's compose f with itself. So it's going to look like f of x. So we start by writing f of x, and when we get to x, we put in f of x, and we immediately get to f of x, or x. So we have x squared. So that's think of that as the part that I'm putting in. And then my regular f of x right here, that's going to be the squared part. And you can go ahead and simplify this a little bit because it does not affect the domain. Doing this exponent to a power does not affect the domain, so that's okay to do that. And the domain of this new function is all real numbers. Okay, that's the end of this example.